Hi, in this video I'm going to demonstrate how to identify and estimate and evaluate the multiple variable, multiple predictor regression model. So in addition to the education, I'm also including the gender, I'm also including their experience. By the way, I also included their interaction term, the education multiplied by female and the female multiplied by experience. So our full model is this one, the first line here. I have all the way from beta hat 0 to beta hat 5. Okay, so the reason you see here, this treatment allows both female and male have their own prediction model. Okay, so for example, if we're predicting a male, therefore their female variable should have value of 0. Okay, in that case, all of them are 0. So this will become the effective prediction model for the male. So within the within the male, when you do the prediction, a male with the same level of experience, but their education is different by 1 year, and this is going to be the amount of difference in their wage. Okay, and this is the female model. Of course, the female variable is going to be equal to 1, and this is their effective model. So as you can see that female has different intercept, different slope for the different predictors. So as you can see that we are actually modeling two different groups using the same single model if you're allowing the intercept to happen like this. Okay, so without further ado, let me jump to the wage data. So I'm gonna just gonna leave all the essential variables here. Okay, I'm just going to move the female here. Okay, but we cannot use it as is, so we're gonna keep the variable name as a female. Okay, but I'm going to change it using the if statement. If this is female, let me turn on the play. If it's a female, it's going to be 1. If it's a male, it's going to be 0. Okay, in the double click, so we have coded correctly. So if you highlight F column, you can see here average is 47.9. So it means 48% of our observations are from female group. Okay, so with this ready, we need to do the interaction term. Okay, but we need to get rid of this. Oops. With this, you need to paste it as a value, because this column is dependent upon this particular column. The disadvantage of using the Excel analysis toolpack here is that all your independent variable has to be right next to each other. So that's a little bit inconvenient. Here is a female times education. I'm also going to do female times experience. Okay. What I'm going to do is female column multiply the education, and female column multiply by the experience. Okay, so if you're a male, you don't get to have those values, right? If you're a female, you have those values. So with this, I think all our independent variables are ready for us to model. 1, 2, 3, 4, 5. So we have exactly 5 different models here. Okay, so let's go. Regression. Do I have the correct range? Yeah, exactly. Good. And then with this, you need to be from C all the way to G527. Okay. The first row is label, and I'm going to output it to somewhere here. We're going to give enough space. Okay. Maybe I'll put the residual, which is good, fine. I can confirm using my manual result. Residual plot is fine too. So I'm going to click OK. Thanks for reminding me. So you are looking at a multiple residual plot because we have a multiple predictors here. So I'll just leave it here. These are the model predictors. Okay, let's look at those one by one. Okay, or before that, let me move all these to where there should be. Present them with a nice layout here. This one is unnecessary, so I'm going to remove it. Okay, so this is an Excel prediction result. Here's my coefficient. Okay, here are all the standard error. So these are my these are actually the p-values. Okay, so except female pose a little bit of concern, which is greater than 0.05. So if you look at their confidence interval ranging from negative 0.26 to positive 5.432. So 0 is actually included within this range, which becomes a little bit of concern. However, if you think about that from the earlier model, this coefficient will be contributed toward the intercept. So I'm not going to worry too much about this. Okay, I'm not going to worry too much about this. So we have other predictors will have they all have a statistical significance that is less than 0.05, p-value less than 0.05, which is good. So what I'm going to do here is I'm going to do the prediction here manually. Okay, say manual prediction, residual based on manual operation. Okay, so I know that these are very accurate, but because you need to know how to utilize the model results. Okay, so I mean, it's not that whenever you come out with a model estimation, you always have to do these steps, but here we're still in a learning phase. Okay, therefore, I personally think this is a very important practice, that you rely on these coefficients and using different value of the independent variable to come out with a prediction. So here, intercept plus, right? But I need this intercept to be absolute referenced. I'm going to slow down here a little bit because it's very easy to make a mistake. Multiply with what? Multiply with education, okay? Plus multiply with experience itself plus female, multiply with the female value, female education interaction, multiply with interacted value, multiply with interaction value. So this is exactly the same result. Okay, same result. I just thought about a different way of doing this thing, which is much more easier. So let me show that one quickly. So copy all of them. Okay, copy all of them and paste it here, but transpose them. Okay, transpose them so that their coefficients are right above the variable name. Okay, trust me, I know what I'm doing. This one is actually the intercept, but it's okay. No, it's not okay. So we're gonna do insert it. I'm gonna do it like this. Okay, so for here, let's say intercept, because all our intercept is equal to 1. Okay, so we're going to put all the intercepts equal to 1. In that case, 1 multiplied by this is basically equal to the coefficient. Okay, so I'm going to use something called a sum product. You should thanking me for showing you how to use this function. This is a very useful function. Okay, we multiply 1 by 1 like this. So if you formulate your equation like this, a formula like this, it means C1 multiply C3 plus C2 multiply D3 and so forth. So this should perform exactly the same task because I also absolute reference the first row. So even you double click to fill it, rest of the results should be exactly the same. So residual wise, it's going to be the same, right? It's the actual value minus this. Your residual should have the same value. We'll also do the square of the residual. Like this. So this quantity here added together should be exactly the same with this quantity right here. Sum square of your residual, or what I used to call it as SSE. Okay. So yeah, this is pretty much it. The model and how to predict based on the model prediction, model estimation, right? And then how to interpret it. So interpretation, you can follow this. Okay, interpretation, you can follow this. So if you're really curious, I can provide the result in here just in a second. So here, as you can see, that I finished my calculation here. This is for male group. For the same male, with the same year of experience, with a 1 year increase in education, you can see that $72.55 increase in the wage. Okay, they're starting. If someone has a 0 year education with a 0 year of experience, their wage is actually negative $4.1590. Okay, with the same people with the same level of education, with a 1 year increase in experience, that will give you additional $0.1128 increase in the wage. This is for the males, okay? However, for the female, you're looking at a different number here. They're starting low, right? If you have 0 education, 0 experience, their starting salary is actually negative 1.57, okay? And for the 2 females with the same year of experience, with a 1 year increase in education, will only give you $0.4761 increase in wage, which is way much lower than the male group here. Okay. Also, if you look at the experience, with the same amount of education, if 2 female had the same amount of education, the 1 year increase in experience give her I think almost 2 cents increase in her wage. Okay. You can see that this is very, very important. This model tells you a couple of important things. If you don't have any education, if you don't have any experience, either you are female or male, you are contributing negatively to the society because you are not making money. Okay? If you are the importance of education actually outweighs the importance of experience. Regardless of a female and male, there are coefficients on the education. It's much bigger than that of the experience. That is the second important observation. The third important observation is what? The gender difference is actually quite significant. Okay, if it's a female going to 1 year school, it'll only give you 47 cents, but that is 72 cents for the males. Okay, this is not a very good thing. The gender difference is not a good thing. I hope this is not happening to you guys. But this is quite old data back in 1976, so things may be a little different back then. Okay, so gender difference is a third very important things here. So I think simple model, right? We started from the simple model. However, we can have a really, really rich discussion based on the final results. Okay, so this is the beauty of building a good model. You can keep adding more stuff here, right? If you remember this data set, we actually had more information than these: the region, the industry, right? The tenure. Tenure means the number of years for the current employer. So all these things can be added together to help you make a better model. So here, I'm not going to spend more time in discussing the residual plot because there's really nothing you can fix anyway, unless you decided to spend a lot of time to kind of improve the model to make it as your dissertation. But again, the data is old. People will question the timeliness of your research. Here, this is the residual plot I showed you earlier. Residual plot between the experience and residual plot with on the experience predictor. This residual plot also reported the interaction terms. I wouldn't put too much emphasis here. The residual plot on the education, okay, which is exactly the same as you've seen earlier. Okay, so this hands-on, this modeling process involves multiple steps, right? So I'm going to share this document with you. On the next assignment I'm going to let you work on, you are going to be doing something much similar. Therefore, this is a very important document for you. Okay, thank you. I will stop here. I will see you in next video.